So run through of the worksheet for the alkyl halides, just 3 questions, 1 per section. Each question, of course, with multiple. So first question, draw and name all the possible isomers. I love questions like this because they hit so many things right there. You have to be able to think about drawing the structures, which structures are redundant, and then once you've drawn them, you have to name them. I mean, it's a great way to test so many fundamental things. So anyway, the way I like to approach it is systematically. We want all the possible isomers, so I'll start off with the isomers that have got a 5-carbon chain. Okay, so 5 carbon in a chain, and I can put the bromine onto the first carbon. If I identify my chain, there it is, 1, 2, 3, 4, the sort of M bit there, sort of elongated M, so the bromine can go on the first carbon, can go on the second carbon, or it can go on the third carbon. So we get 1 bromopentane, 2 bromopentane, or 3 bromopentane. 4 bromopentane would be a wrong naming because 4 bromopentane is the same as 2 bromopentane. It's just you started numbering at the wrong end. So 1, 2, 3, 4. 4 bromopentane, same as 2 bromo. And in the same way, if one was to erroneously say 5 bromopentane, it's the same as 1 bromopentane. So anyway, there are the 3 structural isomers where you've got 1 bromine on a 5-carbon chain. But there are other isomers. We also have to worry at times about geometric isomers, that's cis-trans or EZ, and then optical isomers or enantiomers. Now when you just got chain alkanes, you don't have to worry about EZ, which is only for alkenes, or cis-trans, which is an old version of EZ for alkenes, but is also associated with rings because you can't rotate around double bonds. You can't rotate around rings. Okay, but here we can rotate all we want. So those geometric isomers, the EZ, the cis-trans, unimportant. However, you might have the possibility of optical isomers, of enantiomers, if you have a carbon that has 4 different things attached to it, because that's the quick and dirty way that you know right now of identifying whether or not you can have enantiomers. So we have to look at all our carbons here and see if we have one in which there's 4 different things attached to it. Now the easiest thing to do is to just count the hydrogens. So this carbon's got 2 bonds, so 2 hydrogens. This one 2 bonds, so 2 hydrogens, 2 hydrogens, 2 hydrogens, 3 hydrogens. So if it's got more than 1 hydrogen, it can't have 4 different things. Over here, 2, 3, 2, 3. Ooh, 1 hydrogen there. So this carbon's got a hydrogen and a bromine, but it has an ethyl group and an ethyl group attached to it. So it has 2 different things, only 1 hydrogen, but 2 identical ethyl groups. This one here though, carbon 1 is fine, carbon 5 is fine, carbon 4, carbon 3, but look at carbon 2. Let's put in that hydrogen on carbon 2 to emphasize things. Carbon 2 has a bromine and a hydrogen, a methyl group, because that's all that this 1 carbon is to carbon 2, it's a methyl group, and then a propyl group. So there's 4 different things on carbon 2. Thus we have enantiomers possible. So first thing we have to do when we're thinking about enantiomers around a particular atom is assign priorities to help us name it and classify it. So we look for the atoms bonded in order of atomic mass. Well, bromine is obviously the top priority, hydrogen the lowest priority, but then we have the carbon 2 is bonded to 2 carbons. Which of those 2 carbons is the higher priority? Well, carbon 1 here only has 3 hydrogens attached to it. Carbon 3 has not only got 2 hydrogens, but it's got another carbon. So that means that the propyl group effectively is a higher priority than the methyl group. So there's our connectivity, there's our priorities. Now we need to draw the 2 different enantiomers. Now the easiest way I know of to do this is you just draw your carbon, a tetrahedral carbon, the one that's important. So you've got 2 of the groups are in the plane. So here I've drawn the bromine and the propyl group in the plane, and then 1 going away, 1 coming out at you. And in order to get the enantiomer of that, you just draw the same thing, but switch the ones going out and in at you. So these 2 are mirror images. They're non-superimposable. We know that because they are enantiomers, because you've got a carbon with 4 different things around it, and that's the only weird thing in the molecule. Okay, I toyed with making these, but I thought, now you've seen enough of those models, but hopefully you can appreciate that these are mirror images of each other. Now let's assign R and S. Take the one with the hydrogen going away from us because that's the easier one to immediately apply the rules. Bromine number 1, propyl number 2, methyl number 3, we go clockwise. Lowest priority going away from us, going clockwise, is R. Now let's think about this one here in which the lowest priority is coming out at us. That means everything's flipped. So priority bromine 1, propyl 2, methyl 3, so we go clockwise, but lowest priority is coming out at us, so clockwise here means S. So we got R, 2-bromopentane, and S, 2-bromopentane. 4 of the 11 isomers have a 5-carbon chain. Now let's move to where the long chain is 4 carbons, which means we've got to have 4 carbons and a methyl group on it. So the fundamental structure is here, 1, 2, 3, 4 carbons with that methyl group coming off it. Doesn't matter which end I put it off, because if I ignore the bromine, that and those carbons are the same. Okay, so it's a 2-methyl bromine, and now let's put on the bromine. Sorry, 2-methyl butane, and now let's put on the bromine. So I can put it on carbon 1. I can put it on carbon 2. I can put it on carbon 3. Although now note, I'm just changing the name for fun to 2-bromo-3-methyl. Doesn't matter. It's a different carbon from any of these other ones. And then finally, I could put it on what would have been carbon 4 here, but as soon as I put it there, now that will become the dominant one, so it becomes 1-bromo-2,3-methyl butane. So there are the 4 structural isomers possible for 4 carbons. Okay, out of the C5H11, a 4-carbon chain with a methyl group popping off it. Again, just the 4 different possible carbons that the bromine can go on relative to the methyl group, 1, 2, 3, 4, and of course name can change based on the numbering order, but it's still a methyl butane. Now again, let us investigate the possibility of enantiomers. If we look at the 2-bromo, 2-methyl down here, carbon 1's got 3 hydrogens on it, carbon 2's got a bromine and ethyl group, but 2 methyls, so that's fine. Carbon 3's got 2 hydrogens, carbon 4's got 3 hydrogens. Going over here, carbon 1 has got 2 hydrogens, bromine another carbon. Carbon 2's got 2 hydrogens. Carbon 3's only got 1 hydrogen, but then it's got these 2 methyl groups, and of course carbon 4 has got 3 hydrogens. But here, let's look at 1-bromo-2-methyl butane. Carbon 1's got 2 hydrogens, carbon 3's got 2 hydrogens, carbon 4's got 3 hydrogens, but this carbon 2 here, let's add in its hydrogen, it's got 1 hydrogen, it's got a methyl group, it's got an ethyl group, and then it has a carbon that's got a bromine on it. So it's got 4 different groups associated with it. So carbon 2 there is a stereogenic carbon, what some people would have in the old days called a chiral carbon. Thus we have the 2 possible enantiomers associated with that. Drawing it out, there's the carbon that's got the 4 things. Again here I'm just going to keep the CH3 and the bromine 1 in the plane, and then to draw in the other enantiomer I would have flipped around the hydrogen and the ethyls. Signing priorities, bromine is going to be the top one, right? This is a carbon that goes to a bromine, so that's priority number 1. Ethyl is priority number 2. Methyl priority number 3, the hydrogen going back, so we go 1, 2, 3, we're going anti-clockwise, so it's S. Again here we're going anti-clockwise, 1, 2, 3, but the hydrogen's coming out at us, so anti-clockwise here with the lowest priority coming out at us, anti-clockwise is R. Let's do the same thing over with the 2-bromo-3-butyl butane. Which hydrogen, which carbon are we interested in? Well, carbon here 4 has got 3 hydrogens. This carbon's got 2 methyl groups. Carbon 1 at the end here has got 3 hydrogens, but carbon 2 again, it's got a bromine, it's got a methyl group, it's got what I would call an isopropyl group, and of course it has a hydrogen. So let's draw the two possible isomers. Going to, looking at this carbon again, I'm going to keep the isopropyl and the methyl, so in other words that nice little carbon chain here, but interchange the hydrogen and the bromine to be able to draw my two isomers. Bromine number 1 priority, isopropyl group number 2, methyl number 3, so here I'm going clockwise, which makes that the R. And then here again, I'm going clockwise, bromine, isopropyl, methyl, but here the lowest priority is coming out at us, the hydrogen's coming out at us, so clockwise means S. So there we are, we've got 1, 2, 3, 4, 5, 6 of the 11 isomers have a 4-carbon chain. So now we've done 5-carbon chain, 4-carbon chain, 3-carbon chain. The only possible arrangement is where you have a propane that's got 2 methyl groups. You can't have a bromine on this middle carbon because it's already got 4 things bonded to it. So each of those other carbons is identical. So whether I put a bromine on this carbon, this carbon, this carbon, or this carbon, it will always be 1-bromo-2,2-dimethyl propane. So there we are, the 11 possible isomers. I enjoyed that. I hope you did as well.